Hello, we are group MEE41. We studied joint loosening due to vibrations. Team members are Althea Painter, Colin Port, and Alex Thatcher. Our faculty advisor is David M. Pierce, and our sponsors are Pratt & Whitney. Pratt & Whitney are a leading company in the aerospace industry. They have their headquarters in East Hartford, Connecticut.
So now to focus on our project. First, a brief history of bolted joints. These bolted joints are a staple of construction machine designs, and since their emergence of use of these joints, they have been documented to loosen under conditions of cyclic transverse loading. So the goal of this project is to investigate how transverse vibrations of various amplitudes affect the loosening of these joints. So we fabricated a test rig and have begun experimenting the effects of amplitude on the loosening of these joints. And with this data, we intend to develop a generalized relationship between the amplitude of vibration and the loosening of the bolted joint. Additionally, resisting the loosening of the bolted joint is out of the scope of this project.
So in our design process, we began with an ANSYS analysis of our body. As you can see on the left, without any support, there's more deformation than when we've inserted the X-beams for support on the left or on the right.
The CAD drawing of our design rig is shown on the top with our physical rig being shown on the bottom. Our cam, shown by the red arrow, is connected to our arm shown in the blue, which is connected to our body, shown in yellow, which consists of the entire rig. Within the body is our bolted joint and our load cell, which would measure these signal responses. This is the top view of our drawing, showing the cam slotted into our gear and motor box assembly. And shown here is our isometric view of our design rig.
So as Colin mentioned, the armature is important for our design features, mainly because it can be taken on and off. This is important to change the amplitudes that we're testing against the bolted joint. Also, since our amplitudes are so small and sensitive, we wanted to make sure there's minimal slack in the arm.
Another key component of our design is the off-centered cam. This off-centered cam is what produces the amplitude of the vibration in the test. The connection between the armature and the motor crankshaft is offset by a specified distance, which when rotated about the crankshaft axis, this produces a cyclic displacement. This displacement is transferred through the armature to the top vibrating plate in the bolted joint assembly, and this provides the amplitude. In the next slide, we will discuss our data collection setup.
In terms of data collection, we will be using our load cell as mentioned previously in our design slide. It will be sending signals of experience from a bolted joint loosening, sending to an amp, which will increase these signals, which will then send those signals to our DAC instrument, which will create plotted data on a computer.
Here's a video of our rig running. It's running. As you can see, as the rig is running, because the cam is off-centered, it's pushing the plate forward and backward by our selected amplitude. As you can see on the top, the bolt is spinning. This means that it's loosening.
So here we have a quick visual of our experimentation matrix. We plan to experiment with altered preload and amplitude combinations. The stroke length shown on the left is equal to twice the amplitude that we want to test. And during experimentation, we will record the time in seconds that it takes for the bolt preloads to asymptote. For each individual box here, we will have 5 individual tests. So at this time, while we do not have a graph of our own collected data, the graph shown above is the standard that we are working to create. We expect to see a trend that with increased amplitude, the bolted joint will loosen at a quicker rate and it will loosen more.
To summarize, the purpose of this project was to analyze and test bolted joint loosening based on various amplitudes and preloads. We successfully replicated a simulation of bolted joint loosening, and we will further test amplitudes and different preloads. Upon future improvements, we would improve test reproducibility by using different and cheaper materials. By improving test repeatability, we would change to make quicker bolted connections and allow for easier load cell accessibility. Thank you.